So you are told here the marginal revenue and the average cost functions of biashara are given below. So they have given us the marginal revenue. Marginal revenue equals 40Q minus 3Q squared. Minus 3Q squared. And then they have given us AC. Of course, AC stands for average cost. Average cost is 2Q minus 10 plus 25 over Q. Plus 25 over Q. So what do they want us to give them at the end of the day, ladies and gentlemen? They want us, number one, to give them the profit function. So they want us, number one, to give them the profit function, and then number two, the maximum profit. So how do we get profit, ladies and gentlemen? Remember that for us to be able to get our profit, which is normally designated as pi, pi will always be equal to total revenue minus total cost. Total revenue minus total cost. So I want us to get the total revenue. So from where are we going to get this total revenue? Ladies and gentlemen, we are going to get total revenue from the marginal revenue. They have given us the marginal revenue. Remember, ladies and gentlemen, whenever you are given total revenue and the examiner wants you to get marginal revenue, if you are given total revenue and then somebody wants you to get marginal revenue, this way we shall be differentiating. This way, always do what here? Differentiate. So when you want to get the marginal is for one, the incremental, the minute, the fiber revenue. So when you want to get this fiber revenue from the total revenue, what do? We differentiate the total revenue function. i.e., very important, that our marginal revenue will be equal to change in revenue all over change in what here? All over change in X. To get marginal revenue, ladies and gentlemen, we normally differentiate the revenue function. This means gradient. This means differentiating. Now, how about this other way around, where the examiner gives you marginal, the small revenues, and then he expects you to get total revenue? So, ladies and gentlemen, the other side of the coin, if you are given marginal revenue and the examiner wants us to ascertain total revenue, then what we shall do here is to integrate. We integrate marginal revenue for us to be able to get total revenue. This is very important, ladies and gentlemen, for us today. Here, what they have done, they have given me marginal revenue, and they would want me to give them the total revenue. I like this. So how will I get this? How will I get this? Ladies and gentlemen, listen very carefully. For us to be able to get total revenue out of whatever that we have here, what we'll need to do is to come and integrate the marginal revenue. This is an elongated S. Elongated S, which is a symbol of integration. Elongated S for sum. We shall sum the fiber small revenues. We sum them up for us to be able to get the total revenue. Now, ladies and gentlemen, please remember a quick reminder. If you are told here to integrate ax raised to power n, if you're told here to integrate ax raised to power n, is there anybody who can remind us that formula of integration? Can somebody remind us the formula of integration? Remember, this is the symbol of integration. Somebody tells you to integrate ax raised to n. Ladies and gentlemen, integrating ax raised to n, this one is quite an easy thing. What I'll do, I'll come and increase the power by 1. We increase the power by 1, and then we divide by the new power. We increase the power by 1, and then we divide by what here? We divide by the new power. Anytime we talk about integration, ladies and gentlemen, the key thing that will always come to my mind, is that integration, which is sum, elongated S here for summation. Integration means that we increase the power by 1, and then we divide by the new power, and then, of course, never forget to add the constant of what here? The constant of integration. Ladies and gentlemen, let me make this even clearer. If somebody tells you to integrate 7x raised to power 6, 7x raised to power 6, ladies and gentlemen, integration. This will be 7x raised to a new power. How do we get our new power? To get our new power, ladies and gentlemen, to get our new power, we shall always increase the old power by 1. So in this case here, this will be 6 plus 1, which gives me 7. All over what here? The new power, which is 7. And then, of course, as usual, it cannot end without a constant of integration. It can't end without a constant of integration. Are you able to hear me, ladies and gentlemen? There is a student who is saying that he or she can't hear me. How about the other students? Are you able to hear me? How about the other students? Are you able to hear me? Yes. Yes. So the problem then will be very clear. The other side, on the other side of the students here, that student must be having a problem with their internet, yes. Their internet, yes. So then at the end of the day, what do we have here? These 7 and 7 cancels out. So it cancels out, giving me x raised to 7 plus the constant of integration, which later on I'll be explaining to you. Very important. So ladies and gentlemen, here we are. What if somebody tells you to integrate this one, x plus perhaps 5? If somebody tells me to integrate x plus 5 with respect to x, there is no problem. What I'll need to do is to integrate one term at a time. We shall integrate one term at a time, and I will start with this term here, x. But again, remember, when you see a term like this, x alone, it has got an implied raised to what here? An implied raised to 1. It has got an implied raised to 1. This is an implied. It's there, it's there. So when I'm integrating, I have to be cognizant of that fact. So then how do I go ahead and integrate? To integrate this, I'll increase the power by 1. So then this will be x raised to power 2, all over 2. So this is a constant. A constant does not disappear in integration. We don't lose anything. In integration, ladies and gentlemen, whenever you see a constant like this, the easier way of you remembering, whenever you see a constant like this in integration, it takes up the variable of the function. After integrating it, we expect it to take up the variable of what here, somebody, the variable of the function here. And I've got so many ways of explaining this. We've got so many ways of explaining this. Ladies and gentlemen, remember whenever you see this kind of a number, this kind of a number has got x to power 0 there. Whenever you see this kind of a number, it must be having x, which is silent, which is raised to power what here? Power 0. Because any number that is raised to power 0, or any letter that is raised to power 0, any letter or number raised to power 0 will always be equal to 1. So then this is the same as saying 5 times 1. So I'm trying to explain why we are adding this. Now listen, if then this is the true representation of this particular term, then how do I integrate this? To integrate, it's all about increasing the old power by 1, and then we divide by the new power. We divide by the new power. So then at the end of the day, we'll end up having 5x raised to power 1 divided by 1, which will end up giving me what here? 5x. And then, ladies and gentlemen, please never forget what I always see students forgetting. The most important thing is that after I've finished my integrals, integrating all the terms, please, you should never forget what here? You should never forget k. You should never forget k. You should never forget K. K is so important. K is so important. K is so important. K is so important. So ladies and gentlemen, now here we are. I would want again to reiterate something very important here, because of course most of us have just come to this meeting right now. So we are a little bit late, but it's important for us to understand here that if you are given marginal means minute. Marginal means incremental per unit, small. If you are given marginal revenue and your interest is to ascertain the total stem, the total revenue, then what you need to do is to come and integrate the marginal. Is to come and integrate the marginal. Is to come and integrate the marginal revenue. Marginal revenue. So we want to integrate this marginal revenue here. So integrate the marginal revenue, which is 40q minus 3q squared. So could you kindly go ahead and integrate this for us? So how do we get to integrate? Integration is a simple thing. Ladies and gentlemen, integration like now this one, I know that there is that implied 1. So when it comes to integrating this, then this will be 40 q raised to power, a new power, which now will be 2. So 40q squared all over the new power, which is what here? Which is 2. All over the new power, that is 2. Minus, ladies and gentlemen, I would want us to integrate these terms separately. We integrate these terms separately. It's very easy. I can say 3q squared. So to integrate, it's increasing the power. It's power by 1. So then it will be 3q raised to power 3. Because initially it was 2. Now after integration, we expect its power to increase by 1. And then at the end of the day, we must divide by what here? The new power. And then don't forget our constant, the constant of integration there, which is our k. Don't forget our constant of integration, which is our k. Don't forget the constant of integration, which is what here? Which is our k. Now, ladies and gentlemen, please go ahead there and simplify these. Go ahead and simplify these for us. It means that our total revenue, which is our R, will be 40 over 2, that is 20q squared minus 3 and 3 cancels out, leaving me with q raised to power 3 plus k. And then I remember the person who taught me this QA a long time ago. He told me that this k is a constant. This k, whenever you see k, for example, in the cost function, whenever I see k in the cost function, k will be fixed cost. In the cost function, constant cost is the fixed cost. But now, ladies and gentlemen, when it comes to revenue, if you are taking your notes there, when it comes to revenue, k will always be equal to what here? 0. When it comes to revenue, k will always be equal to 0. K will always be equal to 0. When it comes to revenues, k will always be equal to 0. But why is that the case? Ladies and gentlemen, for revenue, you have to be quite business thinking student to appreciate straight away that k will be equal to 0 automatically. Why? Because if you tell us, for example, that k is 10, what does that mean if k is to be 10? If k is to be 10, it means that if you sell 0, if you sell nothing, that you're going to have a revenue of 10. Ladies and gentlemen, that is not possible. For revenue, if your quantity sold is 0, your revenue will be 0, not unless you're a thief. It is only thieves who sell nothing, but they receive money. Corruption. Ladies and gentlemen, I would want to emphasize this, that for revenue, k will always be equal to what here? K will always be equal to 0. And therefore, our total revenue will be 20q squared minus q cubed, like that. 20q squared minus q cubed. Can somebody now kindly confirm to us whether we are following, or is there anybody who has any question, kind of a question that you would want to ask? I would want a confirmation from you. Up to there, are we together? Are we together? Up to there, are we together? You know, we are not here to waste your time. No. I would want us to. Yes, thank you very much. Nancy is saying she's following. Yeah. Thank you very much. Great. Now I can continue. So, ladies and gentlemen, don't forget what this examiner wanted us to ascertain. In the first requirement, the examiner wanted us to ascertain the profit function. The examiner wanted us to ascertain the profit function. So what I've done, I know the formula of profit. I know that my profit, ladies and gentlemen, I know that my profit equals revenue minus what? Cost. Profit equals revenue minus cost. So revenue, I've been able to take care of revenue. How about cost? Cost, I'll be able to take care of it very fast from where? From this AC. Because AC stands for average cost, and the one again who taught me in those old days over 20 years ago told me average cost is the same as cost per unit. Average cost. Don't integrate average cost. No, 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 no. Average cost is the same as cost for each unit. And therefore, for us to be able to get, ladies and gentlemen, total cost, you need to take the average cost times the total quantity produced and sold, times the total quantity produced and sold. So I'm repeating this again, that average cost is the same as what your cost per unit. And if you have got cost per unit to get total cost, then you have to take the cost per unit, which is average cost, times number of what year units, and that is it. So in short, what we are saying is that you will take the average cost that you have here. You'll take the average cost that you have here, which is 2Q minus 10 plus 25 over Q. You multiply this by the quantity outside there, which is not known for now. Yes. So please go ahead and open your brackets nicely. When I'm opening my brackets, this Q will have to multiply each one of these terms inside. So then this will be minus 2Q. This will be minus 2Q squared, because this and this. Minus 10Q. Yes. And then lastly, plus what here? Because this and this will cancel out, giving me plus 25. Yes. So already now, I've been able to get what here? My total cost. Please don't forget what they wanted us to do. What they wanted us to do was to derive the profit function. So profit is revenue minus cost. And fortunately, we happen to be having our revenue. Our revenue here is 20Q squared minus Q cubed minus our cost, which has to be put in brackets. Remember, we would want to subtract all the cost items, all the cost terms from where? From the revenue. So I want to put the cost terms in brackets. They want to be subtracted. The function to be subtracted must always be put in brackets. So we have here in brackets here 2Q cubed, 2Q squared, I mean, minus 10Q plus 25, and then that is it. So now the only thing we need to do is to go ahead there and open brackets, because as per body mass, there is nothing inside this bracket here that you can combine. There is nothing inside the brackets here that you can combine. So what we need to do is to go ahead, ladies and gentlemen, and open the brackets here. Would want to go ahead and open the brackets here. So our profit at the end of the day will be equal to, of course, the terms here will remain. So we have 20Q squared minus Q cubed. And then now we have each of the terms inside here will have to change. The sign will have to change. So minus 2Q squared, because minus, whenever you have a minus outside, a minus is very powerful. So minus 2Q squared plus 10Q. All the terms inside here must have their signs changing. Minus 25. Now from there, ladies and gentlemen, our work now will be to put like terms together. Like this 20Q squared, do we have a like term for the same? Yes, I can see minus 2Q squared. Remember, I have to read this sign, which is before. So minus, yes. So 20Q squared minus 2Q squared, this will give us what here? 18Q squared. So I have to tick this because I've taken care of the Q squared term. From there, we have this Q cubed. It doesn't have a partner. What I need to do is to come and tick it there. And then I say minus Q cubed like that. Ladies and gentlemen, from there, we have what here? We have plus 10Q here. Because also it doesn't have a term, a like term, minus this one also, minus 25 like that. So that is it. This is our profit what here? Profit equation, which this examiner wanted us to ascertain. So before I continue, again, I would want some kind of confirmation from you. Is there anybody who has a question? Is there anybody who has a question? If you don't have a question, before I continue, it will be important for me to know that we are together. Are we following? Great. James says he's okay. James says he's okay. How about the other students? It will be very important for me to know whether they are really following. Yeah, David says very okay. Very okay. Following, thank you very much. Okay, thank you very much. Thank you very much. Now, ladies and gentlemen, after that, the next thing that they want us to do, is to give them the maximum profit. I'm quite used to these maximization aspects. So when they want me to give them maximum profit, what do they want me to do? When they want me to give them the maximum profit, ladies and gentlemen, maximum profit, I know for sure that at maximum profit, where profit is maximum here, or even minimum, at maximum or minimum, or even minimum, we have got what we call turning points. And the most important thing you're supposed to know about turning points is that their gradient, if you're to put a tangent here, their gradient always equals what here? 0. Their gradient is always equal to 0. Anything you hear about maximizing profit, minimizing cost, you should always know that the gradient at those particular optimal points, you call them optimal points. The gradient at the optimal point is always equal to what here? 0. And this is what we call the first order condition. This is what we call the first order condition. The first order condition. This is what we call the first order condition. First order condition for maximization and the minimization, that the gradient is always equal to. Now, ladies and gentlemen, again, the moment you mention the word gradient, I know there is something that I'll always have in my mind, that the gradient has got everything to do with differentiation. Gradient has got everything to do with differentiation. Gradient has everything to do with differentiation. And if I could just take you some few miles back, I know you guys are very good at this, but if you could just give me 2 minutes, I take you back to some memory lane here. For differentiation, if you are given y equals ax raised to power n, for differentiation, if you are given y equals ax raised to power n, to get dy over dx, how do we do this? Remember, to get dy over dx, the power has to fall down. The power must do what here? The power must fall down. Remember the concepts of differentiation. Ladies and gentlemen, we are saying that differentiation, the power must fall down. So this power is falling down. So then we'll talk of now x raised to a new power, which will be n minus who? N minus 1. X raised to a new power, which will be n minus what here? N minus 1. So this is a rule of differentiation. If you give me a term like this, y equals x raised to power 5, and you ask me to give you dy over dx, which of course is a terminology for differentiate, then I'll be able to differentiate for you very easily, because the power must come down. 2 things. The power comes down, of course there is 1 there, so it will be 5x raised to a new power. For differentiation power, we expect you take the old power minus 1. So 5 minus 1, that gives us what here? That gives us 4. 5 minus 1, that gives us 4, like that. So, ladies and gentlemen, before I come back to this, if, for example, you are to give me something like y equals 10x raised to power 6 plus 30x plus 50, and then you tell me to differentiate this, how will I be able to differentiate this? It doesn't matter how many terms this thing has. Ladies and gentlemen, at the end of the day, I will differentiate one term at a time. So then what do we have here at the end of the day? The 6 comes down times 10. That gives us 60. X raised to a new power, which will be a reduced power. 60x raised to power 5. Now, ladies and gentlemen, come and differentiate this. Of course, I know there is a 1 up there. When I bring it down, 1 times 30, it makes 30. So it will be 30 x raised to a new power, which will be what there? 0. x raised to a new power, which will be 0, because, ladies and gentlemen, remember the rule of differentiation, the concept of NR, that this 6 comes down, knocks on the 10, gives us 60x raised to a reduced power. The same case here, the 1 comes down, meets the 30, so 30x raised to a new power. New power. Ladies and gentlemen, this is a constant. Remember, for integration, you weren't losing anything. But for differentiation, ladies and gentlemen, differentiation, all constants in this case here do what? They disappear. For differentiation, all constants do what? They disappear. So this 50 does not have x. It's a constant. It disappears. Then at the end of the day, then we'll say that we have here 60x raised to power 5 plus 30. Because, of course, any number raised to 0, any letter raised to 0, x raised to 0 gives me 1. So that leaves me with 30 like that. Great. Now, using that concept, could you kindly go ahead and differentiate this for me? Why are we differentiating the profit equation? It's because they spoke about as maximizing profit. As maximizing profit. To maximize profit, let's first of all get the gradient of the profit. So in this case here, come and apply what we call the first order condition. So my first order condition, it will be d profit over dq. D profit over dq. D profit over dq. So d profit over dq, let's differentiate these terms together. So I would want us to differentiate this. To differentiate is quite a simple thing. What I need to do is to pull down the power. 2, 18, 36. So 36q raised to a new power. The new power here will be 2 minus 1. Which leaves me the 1. It's not wrong, but it's not proper for you to come and tell us raised to power 1. No, no, no. We leave it like that, 36q. Plus, I can see here, minus 3. So 3 comes in front. So 3q raised to a new power there, which will be the reduced power, which will be what here, 2. Plus, of course, this ultimately will end up giving me 10. Will end up giving me 10, 10, 10. Minus 25, of course, 25 is a constant that disappears. So this one here equals what here, somebody? Equals 0, like that. And there we are. And there we are. So, ladies and gentlemen, once we reach there, this first order condition, don't forget that the first order condition, the gradient, must be equated to 0. Why? Simply because on top there, where things are maximum, on top there where things are maximum, we expect the gradient always to be equal to 0. And it is at this particular juncture that we must come and provide a solution. We must come and provide a solution at this juncture. How do we provide the solution? By observation, we realize that this is a quadratic function. And if it's a quadratic function, remember how quadratic functions look like. They look like this. This is aq squared plus bq. If aq squared plus bq plus c equals 0, then q will be equal to minus b plus or minus the square root of b squared minus 4ac. Everything to be divided by what here? 2a. Everything to be divided by 2a. Very important. Everything to be divided by 2a. Everything to be divided by 2a. Everything to be divided by 2a. So, ladies and gentlemen, then, having acknowledged this quadratic equation, quadratic because of the highest power here, which is squared. If the highest power, for example, was 3, we would have spoken about cubic. This is 2. It's quadratic. So then the thing that I need to do is to come and define A, B, and C. So A is the term, or rather the number that comes before Q squared. So before Q squared, what do we have? Which number do we have here? So A is minus 3. A is minus 3. And then we have B. B is a number that comes before a Q. B is a number that comes before a Q. When I look at this entire function, the one that comes before Q is this, 36. So B is 36. And then we have C. C is the constant term, the constant which doesn't have a now Q or X or whatever. So C is 10 like that. So ladies and gentlemen, the moment you hit there, the next thing you need to do for us is to come and now substitute. So please go ahead and plug in the figures, plug them in. So like now we are saying minus b. So this will be minus 36 plus or minus square root of 36 square. I'm plugging in. So b instead of b, I plug in 36. So 36 squared. 36 squared minus 4 times a, which is minus 3, times c. C, which is what here? 10. All over 2 times a here, which is minus 3. Now, I would want you great students of mine to do me a favor. Please, using your calculators, say 36 squared minus 4 times minus 3 times 10. Whatever you get, you take away the square root. You get the square root of that particular number. 36 squared minus 4 times minus 3 times 10 equals. And then whatever you get, you say square root. You give me an answer. I'm so sure you guys have your calculators there. I'm so sure you guys have your calculators there. I'm so sure that you guys have your calculators there. Can somebody help me out as we finish this? I would want us to finish this at exactly 140. 140, and then we agree on the way forward. Then we agree on the way forward, Okay, so please, if you have a calculator, could you kindly give me this figure? 36 squared minus 4 times minus 3 times 10. Whatever you get there, that answer, simply give us the square root. Simply give us the square root. David gives us 37.63. Can someone else confirm that whatever David is giving us is truthful, is correct? I would want to hear it from someone else, just for purposes of confirmation. For purposes of confirmation, someone else. After getting the square root, are we able to see that 37.63? Somebody. What are we doing? Using our calculators, 36 squared minus 4 times minus 3 times 10. Whatever we get, we say equals. And then square root. Correct. Thank you very much, Nancy. Correct. So then if that is the case, then we don't have really much. That marks automatically the end of our class. If we don't have really here a problem with that figure, then our Q will be equal to minus 36 plus or minus the one that is inside here is 37.63. All over 2 times minus 3 is minus 6. If that is correct, if that is truthful, what I'll need to do is to come and give them Q1 and the Q2. So come and provide here Q1, and then we have Q2. Remember, why are we providing Q1 and Q2? It's because of this plus and minus, which are at the same position, plus and minus. So Q1 will be, when we consider the plus sign alone, which will be minus 36 plus 37.63 over minus 6. And then, of course, Q2 will be when we consider the negative, which will be minus 36 minus 37.63 all over minus 6, like that. So I want you to be very good to me. Could you kindly get the numerator? The numerator. Whatever you get in the numerator here, you divide by minus 6. Give me an answer, the first Q. Give me an answer, the first Q. What do we have there? Give me an answer, the first Q. Be quite low on this. You take minus 36 plus 37.63 equals. And then you say divide by minus 6. Divided by minus 6. So Nancy is giving me 12.27. 12.27. And I would want to really get another person also confirming the same. Can another person confirm this for us? So as we finish, let's finish with power. Let's finish with power. Nancy is saying that the second one, I don't know. Which one is supposed to be minus 0.27? I want to believe is the first one, eh? Please give us the answers. Give us the answers, and then I tell you something nice before we finish. So perhaps Nancy is making that correction, minus 0.27, and I would expect somebody. Yes, so the first one is minus 0.27. How about the second one? How about the second one? So the first one is minus 0.27. And then now the second one. And then, ladies and gentlemen, please remember that an examiner nowadays has allowed us to make use of a calculator. If you have got good calculators like the FX570MS, FX570MS, you don't even have to remember this formula of quadratic. Nothing. You don't need to remember that. You only need that calculator of FX570, and then I show you how it works out. So please give me the second figure here. Time is not on our side. We want to grab something before we go back to our workplaces. 12.27. Thank you very much. So, ladies and gentlemen, we have come to the end of this. Of course, in terms of giving advice, it's not possible for us to have a negative quantity. Negative quantity, not possible. Right? So therefore, the profit maximizing output is 12.27. This is the profit maximizing output, and it is the one that I will plug in here to be able to get what the examiner wanted me to ascertain, which is what here, maximum profit, not this. Remember the profit equation. Remember somewhere we had the profit. So in this profit equation, just go there and do what here, substitute. You just go there and then you substitute. Ladies and gentlemen, my name is Dr. Joshua Aura. I teach this QA at RCM. We teach this QA at RCM College. And most importantly is our online offerings. Trust you, ladies and gentlemen, with this kind of a class like we have had today, there is no good reason as to why a student should even think about attending anybody's what here? Physical classes. No good reason. No good reason. Because like now you can imagine like this class that I've just done, it's recorded here. So I'll be able to pull it down very fast here, upload it on our website, and then I send it to you right away. So you'll have a situation where you'll be able to look at this particular video more than once. So I urge you to really look at all our online offerings that we have. Like you can opt to go for just the videos alone. You can opt to go for Zoom alone. You can opt to go for videos plus what here plus Zoom. All these are at affordable cost, 2,000, 2,500, very much affordable. And of course, should you also want, for example, to get our revision access to our revision kits, yes, we also sell them, or rather, you can talk of videos plus Zoom plus books, but the person who will be able to give you this information very fast is a lady called Caro. And the Caro tampata wapi kwa hii number 0719 525,000. 0719 525,000. Otherwise, it has been a pleasure hosting you today. I look forward to having another session again free of charge with you, perhaps tomorrow or even today in the evening. I'll be able to. Yes. So I can see what David is asking there, whether we could have